Honors Algebra 2, Chapter 4, Section 7. The goal is to solve quadratics by completing the square. So the last two sections we're going to cover today and tomorrow is how to solve quadratics. We've already talked about solving quadratics using factoring. We're going to use completing the square today, and then tomorrow we'll use the quadratic formula. So completing the square with SpongeBob SquarePants, yeah. So algebra trial. So if we have x squared plus 6x. If we're going to show this or model this through algebra trials, when we're using these, if you've not seen them before, this square has dimensions of x by x. So then the area of it would be x squared. And so we can do that same thing with the other pieces, where the dimensions of this are x by 1, and then this is 1 by 1. And so we can use the area of these, of x and 1, to represent this expression x squared plus 6x. So we have an x squared here, and these are all x's. And the reason why I have them set up like this, they're not all straight in a line, I have some down here, is because we want to complete the square. So we want to make this into a square. So we need this side to be the same as this side. So we need an equal amount of x's on both sides. So then this is really going to be x plus 3, because we have an x here, and then 1, 1, 1. And then this is going to be an x, and then a 1, 1, 1. So we have x plus 3 on this side as well. So the question is, what do we need to add to this? What do we need to put in here to complete the square, to make it a perfect square? And so we need to place in these squares in here, or we can drag them from the top here. We want to place these in there to make a perfect square. So how many of these do we actually need to move in here? And you probably can already tell, but I'll go through the process. So here we go. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 3 by 3, so we have 9. So to complete this, to make this a perfect square, we need to add 9 to that. Now what's the point of that? Why would you want to add 9 to this? Well, it completes a square, or makes this a perfect square. So when we factor this, we have x, 3, 3. So now this is x plus 3 and x plus 3, or x plus 3 squared, because this is a perfect square. And so we're trying to figure out what number we need to add to it to complete the square. And so that pattern continues, and we can fill out this chart, which we're actually going to do in a second, to figure out what do we need to add here to all of these to complete the square, and then what's the factored form for that. So we're going to do that here. And so x squared plus 2x, if I pull out an x squared and then pull out 2x, so here's 1x, and here's another one, and then put it here. So then what would we need to do to complete the square? We just need to add 1. So we're going to add 1 to that. Now if we want to factor that, that's going to be x plus, and we have to have 1 and 1, and then the OI would be 2x. So that factoring we're working on is really huge here to help us factor this quickly, and we can rewrite this as x plus 1 squared. Let's do that again for x. So x squared plus 4x. So we have 1, 2, 3, and 4 of them here. So we want to put 2 on one side, and then we're going to rotate this. And then what do we need to add? To complete the square? We need to add in the 4 in here. 1, 2, 3, and 4. So then that would actually make this a perfect square. The dimensions would be the same on every side. So it would be x plus 2 and x plus 2 if you see the factored form. And so you can actually use the picture to help you factor it. X plus 2 and x plus 2. You can see that even before you put in these 4, but we need to add 4 here to make that a perfect square. So on this one, the pattern, if we just set it up a little bit, we have the x squared and we have 10. So we're going to have 5 on this side. And so right now you can probably see what it's going to be. We need 5 of these on one side, and then I would need 5 on the other side. So, but the factor here is going to be x plus 5. So this side is going to be x plus 5. That's what the factor is going to be. So this is going to factor to x plus 5 squared, and the 5 squared is 25. or the 5 times the 5 here is going to be 25 we need to add to it. So to complete the square, we need 25, and it would factor to x plus 5 squared. And so let's go to the table here where we can actually see we needed to add 9 here, we needed to add 1 here, we needed to add 4 here, we needed to add 25. So can you see the pattern? How do you go from 6 to 9, 2 to 1, 4 to 4, 10 to 25? What would you add here to the x squared plus 8x? And it ends up being 16. So how are we getting that? Well, we take this 8, you cut it in half, you have 4, and then if you square that, you get 16. That pattern works for all this. Half of 6 is 3, 3 squared is 9. Half of 2 is 1, 1 squared is 1. Half of 4 is 2, 2 squared is 4. Half of 10 is 5, 5 squared is 25. And so that's actually the rule we use here to figure out what we need to add to complete the square. So it's b over 2 squared. That's the quantity you need to add to complete the square. Now the factor form of the first one is x plus 3 squared. The second one was x plus 1 squared. Third one was x plus 2 squared. The last one here was x plus 5 squared. That's what we already did. Now the pattern here says it's going to be x plus, and then it's half of that b value. So that quantity there is going to be half of our b value. So that pattern really helps us be able to factor it quickly and find the value we need to add to complete the square. And so here's the actual rule. This is the book's rule to complete the square. Hopefully you can see the patterns might help you understand what's happening here. But the b over 2 squared, this term is what you want to add to it to complete the square. And then when you factor it, you get this quantity squared. Half of b is the other term added to x. So how do you solve? We did this in the past few days. X squared equals 9. We want to square root both sides. And our answer of x is plus or minus the square root of 9, which is 3. Don't forget your plus or minus. We've already done that. We've also done this one where you still square root both sides because the power has been isolated. And you get x minus 2 equals, again, plus or minus 3. But now to solve for x, we need to add 2 to both sides. So x equals 2 plus or minus 3. So then we have two answers. We have 2 plus 3, which is 5. Or we have 2 minus 3, which is negative 1. And so we're going to use those same skills in these problems. So now we're going to put it all together here. Let's complete the square. So for this problem, when we're looking at this quantity here, if we can factor it first, we should try factoring it. And this doesn't factor. There's no, we look at that. X, they have to be opposite. And then the two numbers that multiply to be negative 4, but add to be negative 4. There's none of them. It doesn't work. And so we need to use a different method. I always look for factoring real quick. If I can't factor, then we try maybe completing the square. And for completing the square, I want to make sure I have the value here that would complete it. So if I want to even add the 4 to both sides, so I have this. Now I can leave a blank here to figure out what I need to add to both sides to complete the square. When you complete the square, you add a quantity to both sides, so this trinomial becomes a perfect square. And to find that again, you take your b value, you cut it in half. Half of negative 4 is negative 2. So you take half of that, which is negative 2, and then we square it. So that value is positive 4. That is the value we want to add here. So now this quantity here, x squared minus 4x plus 4, that trinomial, then we can factor it. And it always factors to x, and then whatever half your b value is. Half of negative 4 is negative 2. That quantity squared equals, this side says 8. From this point, it's the same thing we were just doing on the previous problem, where we can just square root both sides. So it's the same thing as the problem up here. Let's square root both sides. So we have x minus 2 equals plus or minus the square root of 8. And remember, square root of 8, we could rewrite it as 2 square roots of 2, simplify that radical. And we add 2 to both sides. So we have 2 plus or minus 2 root 2 would be the final answer of that. So it's kind of putting it all together with how to solve your roots, having the plus or minus, how to simplify your radicals along with completing the square. So same thing for this problem. We can't factor it, so we can move the 9 to the right-hand side. So x squared plus 14x equals negative 9. Notice how I leave a space here. I leave a space to allow me to complete the square. I want to see what that term's going to be. So what do I add to both sides to complete the square? Again, here's our b value is 14. Half of it's 7. I square that, I get 49. I have to add it to both sides to keep my equation equivalent. So now I can factor this. It always factors to half our b value, x plus half our b value. And that quantity, negative 9 plus 49 is 40. So now we can square root both sides. X plus 70, or 7, x plus 7 equals plus or minus root 40 is 2 root 10. Then subtract 7 to both sides. You have negative 7 plus or minus 2 root 10. And that would be the exact answer. It's a little more difficult. So here we have an a value. Now, we haven't talked about that yet. Completing the square only works when your a value is 1. A has to equal 1 for completing the square. It's the only way you can complete the square is have a1. So we need to get rid of that. So we actually need to divide both sides by 12. Now when we do that, the first term, 12 divided 12 is 1, plus, that doesn't divide evenly. So I need to divide both numbers. Shh. You be quiet. You need to divide both numbers by 6. So we have 5 halves, x, and then minus 1 half equals 0. So we still need to do 6/12. Now I can add that to the right hand side. So x squared plus 5 halves equals 1 half. Now we can still go through and complete the square to both sides. So it's still half your b value. So if I take 5/4, 5 halves, and I find half of it, it's like multiplying by half. I get 5/4. Then I need to square that, and to square that I get 25/16. So that's what I want to add to both sides, 25/16. Now when I actually factor it, it's still using that pattern. Half of 5 halves is 5/4. That quantity squared equals, we have 1 half plus 25/16. So that's 8/16 plus 25/16, or 33/16. And then we can square root both sides. So you have x plus 5/4 equals the square root of 33/16. We can take the square root of the denominator, is 4, and leave the radical in the numerator. That is fine.
Daddy, what are you doing?
I'm teaching them. What are you doing?
Yeah.
You're watching me? Okay, you can watch. Just be quiet. So last step would be to subtract the 5/4 to both sides. So our final answer would be this. So here's another challenge problem. It's the same steps. So you need to do the same thing with this problem we did in the previous problem, the most difficult problem. Get rid of the a value first and then use completing the square. So follow the steps. It's okay to have fractions, but see what you can do. That's your problem to turn in tomorrow. So vertex form is when we had a times the quantity of x minus h squared plus k. So we're trying to write the standard form to vertex form, and to do that we actually use completing the square. So when you complete the square with this trinomial, you keep everything on the same side. So we just make a space to complete the square. So I'm going to leave a blank here and then move the 16 to the right. And so we still want to complete the square. We want to add half our b value 3 squared, which is 9, to both sides. But we're not going to do both sides. If I add 9 to the side and subtract 9 to the same side, I've done the opposite, so it's like I've done nothing to the problem. And so that's really what we're doing. We're going to stay on one side. We'll end up getting it in vertex form. So then we have, this is the quantity we'll end up factoring, and then that part out here becomes our h value. So we end up having plus 7 on the outside. We just factor this, we're done. And this factors to x plus half our b value squared. So putting it in vertex form uses completing the square to break that up and then see our k value and then a perfect square.